Sampling methods. In research, a target population refers to the group of individuals or entities that a researcher is interested in studying. A sample is a smaller subset of the target population that is selected for the purpose of the study. Sampling is the process of selecting a sample from the target population using specific sampling methods. There are 4 main sampling methods commonly used in research. The first one is random sampling. Random sampling involves selecting individuals from the target population at random, without any bias or preference. This can be done using a random number generator, a table of random numbers, or other random selection methods. What are the strengths of random sampling? It's considered the most unbiased and representative sampling method, as each member of the target population has an equal chance of being selected. It minimises the potential for bias and ensures that the sample is representative of the target population. And it is easy to understand and implement. What are the weaknesses of random sampling? It may not always be feasible, especially when the target population is large and spread out. It can be time-consuming and expensive to contact every member of the target population. It may result in a small sample size, which can reduce the generalizability of the findings. Opportunity sampling. Opportunity sampling involves selecting individuals from the target population based on their availability and willingness to participate in the study. This is often used in convenience sampling, where participants are recruited from a specific location or setting, such as a school or workplace. The strengths? It is easy to implement and requires minimal resources. It can be useful in certain situations where it is difficult to contact members of the target population, and it may be more practical when time and resources are limited. The weaknesses? It may not be representative of the target population, as it only includes individuals who are easily accessible or interested in the study. It may result in biased samples, which can affect the generalizability of the findings. It can be difficult to control extraneous variables that may affect the results. Systematic sampling. Systematic sampling involves selecting individuals from the target population at regular intervals, such as every 10th person on a list. What are the strengths? It is easy to understand and implement. It can be useful when the target population is large and spread out. It can be more efficient than random sampling, as it doesn't require contacting every member of target population. Weaknesses. It can introduce an alternative bias if there is a pattern in the list, such as alphabetical order. It may not be representative of the target population if the list is not complete or up to date. It may result in a small sample size, which can reduce the generalizability of the findings. Stratified sampling. Stratified sampling involves dividing the target population into subgroups, or strata, based on specific characteristics, such as age, gender, or geographic location. A sample is then selected from each stratum to ensure that the sample is representative of the target population. Stratified sampling can be useful when there are known differences in the target population that may affect the results of the study. The strengths of stratified sampling? It ensures that each subgroup in the target population is represented in the sample. It can reduce the potential for bias and increase the representativeness of the sample. And it allows for comparisons between subgroups. The weaknesses. It may be time-consuming and require more resources than other sampling methods. It requires accurate information about the target population to divide it into the appropriate strata. It may not be practical when the target population is small or homogeneous. To select a sample using these methods, researchers need to identify the target population and determine the appropriate sampling method based on the research question and the characteristics of the population. Here are some of the principles of sampling that are commonly applied to scientific data. The first one is representativeness. A sample is considered representative if it accurately reflects the characteristics of the larger population from which it was drawn. To achieve representativeness, the sample selection process should be unbiased and based on sound statistical principles. The second is sample size. The size of the sample should be large enough to provide accurate estimates of the population parameters of interest. The required sample size depends on the variability of the population, the level of precision desired, and the confidence level chosen. Randomness. Random sampling involves selecting individuals or units from the population using a random procedure, such as drawing names out of a hat or using a random number generator. This helps to minimize bias and increase the likelihood that the sample is representative of the population. The sampling frame. The sampling frame is the list of all individuals or units in the population from which the sample is drawn. It should be comprehensive and up to date to ensure that all the members of the population have an equal chance of being selected. The sampling method. The sampling method used should be appropriate for the research question and the characteristics of the population. There are several sampling methods, including random sampling, stratified sampling, cluster sampling, and convenience sampling. And lastly, data quality. Sampling can affect the quality of the data collected. It is important to use appropriate sampling techniques to reduce the risk of bias and ensure the accuracy and reliability of the results. By applying these principles, researchers can obtain reliable and valid results that can be generalized to the population of interest.